Bitcoin? A simple explanation. Part 2. The Bitcoin blockchain. So the Bitcoin private key and Bitcoin public address holds the actual Bitcoins. And you can see that these can be created and stored without limit by anyone knowledgeable enough. However, if we only have these, the Bitcoins won't be of any use. We need a payment network which lets you send your Bitcoins to different Bitcoin addresses. The Bitcoin blockchain serves this purpose. The Bitcoin blockchain is basically the list or ledger of all the transactions and all the used Bitcoin public addresses that has ever been made in the Bitcoin network. It is maintained by a large number of highly invested people and groups who take part in the network, known as miners. The easiest way to understand the Bitcoin blockchain is to go back to the very beginning of Bitcoin in the year 2009, at block 0 known as the Genesis block, and then slowly build up from there. I will only need to describe up to block 2 for you to get a good enough idea. I want to emphasize that these things didn't happen as described for the actual Bitcoin blockchain, but is rather a hypothetical scenario which fairly accurately explains how Bitcoin mining and Bitcoin transactions work. Block 0, Genesis block. Block 0 basically has no transaction data, but it still has data such as the date it was created and some other data. This blockchain data is stored on the computers of individual people who have downloaded and run the original Bitcoin wallet program called nodes and/or miners. In our example, we will assume there are only 3 participants which make up all the users in the network. Participants A, B, and C. In the future, many new participants will join the network. The original Bitcoin wallet program and all future variations of the program is free for anyone to download and use. Each of these 3 participants would have had the option to mine Bitcoins, and they would have been able to create Bitcoin public addresses and private keys like described earlier. When they ran the mining software for the first time, at least one Bitcoin public address was created by each of them. So assume participant A has created Bitcoin public address 1, E, C, K, P, 4, etc. Participant B has created Bitcoin public address 1, 4, P, P, 4Z, etc. Participant C has created Bitcoin public address 1, J, 6, 2, K, Z, etc. Now all 3 participants activate their mining software. Since there are currently no Bitcoins in all the world, block 1, the next block of the blockchain will not contain any transactions showing any movement of Bitcoins, but it will show a balance of 50 new Bitcoins created into one of the 3 Bitcoin public addresses shown above owned by participant A, B, or C. New Bitcoins enter the world after every mining round. The way the software decides which miner gets the 50 new Bitcoins is based on a proof-of-work system. On average, new Bitcoins enter the world every 10 minutes, and this rate is set by the computer software. How mining works. So we will assume that all 3 participants turn on their mining software at the same time, and everyone is using the exact same type of computer. These 3 miners all have the same copy of the Bitcoin blockchain, which in its entirety is currently block 0. The mining software now takes the block 0 file data and adds the empty block 1 file data to it, and then expresses this file as a number. We will call this the block 1 computer number. Remember that all data files on a computer are zeros and ones. Then the software begins the mining process by taking a random number called a nonce and adding this random number to the end of the block 1 computer number. Then it creates a one-way SHA-256 hash of this new number, and the result is recorded somewhere. Basically, the rules of the program states that if this resulting number or hash has a certain number of consecutive zeros in front of it, then it proves that that computer has completed the proof of work, and the software automatically creates the 50 new Bitcoins into that participant miner's Bitcoin public address. If the random number doesn't lead to the required number of consecutive zeros, then the computer tries again until it does find one. The proof of work here lies in the fact that mathematically, it takes a certain number of random hashes by the computer before the computer will find one that meets the difficulty requirement of having a hash result with the required number of consecutive zeros in front of it. Every 2 weeks, this difficulty is automatically adjusted by the Bitcoin computer program, which all the miners run by adding or reducing the number of consecutive zeros that are needed before new Bitcoins can be awarded. The more zeros there are, the more difficult it is to solve. The difficulty is changed so that on average about every 10 minutes a new block is solved, and this happens regardless of how many or how few computers are mining. In our example, Each of the three miners have an equal chance of finding the correct hash first because everyone is running the same computer type, and so each computer will create the same number of hashes per second. In modern-day Bitcoin mining, though, different miners have vastly different hash-producing abilities, and this will directly impact on how many blocks they will solve compared to other miners. The more hashes they can make compared to the rest of the miners, the more blocks they will solve. Also, in modern-day mining, the number of hashes required is so huge now that only mining pools or centers with millions and millions of dollars worth of dedicated mining hardware in them can successfully solve new blocks. So we will assume participant A was the first to solve block 1, and their Bitcoin wallet software now shows 50 Bitcoins at address 1ECKP4, etc. Participant A will now broadcast this information to the entire network, and participants B and C will check that participant A's hash number is correct. By simply checking that the number they used leads to the correct hash in that new block, correct hash equals proof that work has been done. If it is correct, then their computers will now also show block 0 plus block 1. The Bitcoin blockchain has now been updated and will look like the following. Block 0, date and time created, plus block 1, date and time created. 50 new Bitcoins at 1 ECKP4, etc. as mining block reward plus solved hash of block 1.